Hi everybody, this is going to be our first video in the matrix unit that we're starting here. And we're going to start off not even really talking about matrices, we're going to be talking about systems of equations because our goal here is to learn how to solve systems of equations with other methods. And matrices are a really great way to solve three variable systems of equations, which we're going to be seeing for the first time today. Okay, so what you need to know is that three variable systems of equations have three equations and three variables. So we're not really just looking at the intersection of lines anymore. We're actually looking at the intersection of planes. And the solution is going to be found where all three planes are intersecting, coming to one common point. And because we have three variables, an x, a y, and a z, our solution is going to be written as an ordered triple. So we need one of each of those values. An x, a y, and a z value will make up our solution. Okay. So let's look at an example here. And we're not going to solve this using matrices. We're going to solve this by hand because I want you to see why we want another method. This is going to be a lot of work, so save yourself a lot of room on your paper. The goal here is to take this three variable system and really strip it down to a two variable system. So what we want to do is we want to create two equations that will have one of the variables canceled out in both of them. So what I look for here is I look for an equation that's going to have some variables cancel out nicely. So let me kind of explain what I mean by that. If we look at the bottom and the middle equation, I could cancel out the y values or the y variables here pretty easily. Okay, I could just subtract these equations or multiply one of them by -1 and then add the equations to cancel out y. So when I do that elimination, I'm going to call the result of that a. And then I have to do another combination of equations that are going to have the y values cancel out. So I'm going to also do elimination between my top and my middle equations, and I'm going to call the result of that b. So I'm going to make a note here, okay? For a, I am going to, when I rewrite it, multiply my bottom equation by a -1. And then for b, in order to get those y's canceled out, I'm going to multiply the middle equation by 6. So let's actually set up these a and b equations that I keep talking about here. So a is what we're going to get when we do elimination between the middle and bottom equation. So we've got 5x plus y plus 2z equals 10. And then I said I was going to multiply that bottom equation by a -1. So we really have -3x minus y plus 8z equals positive 28. Okay, so now we're going to add our equations together. Okay, when we add, we end up with a 2x, the y's cancel, of 10z equal to 38. This is going to be our A equation. Now we're going to do the same thing, the same kind of thing, but for B. So we're going to take the top equation and the middle equation and do elimination. And remember we said we were going to multiply that middle equation by 6. So let's do that as we go. So we get 30x plus 6y plus 12z equals 60. And now we can add these equations together to cancel out the y's. So we get 32x, the y's cancel, we get plus 21z equal to 52. So now we have this A and B equation, and what we're going to do is we're going to take the A and the B equations and we're going to create a new system with those two equations. This new system that we're creating, you'll notice, only has x's and z's. And before we write it, okay, let's kind of strategize here. Okay, we know that we're going to want to do another elimination. So we're going to have to decide, between these two equations, which variable are we going to try to cancel out. I think it's going to be easier to go for the x's. So I'm going to multiply a by 16. Let's do a negative 16 actually as I rewrite this. So when I multiply a by negative 16, we're going to get a negative 32x minus 160z. And then when we do 38 times negative 16, we're going to get negative 608. Okay, and then my second equation, b, is going to go underneath, and we're going to do elimination to cancel out those x's, and we'll be able to actually solve for z now. So when I add x's cancel, I'm going to be left with an equation with a single variable, and once we hit that spot, things start getting easier for us. So we get negative 139z, and then on the other side of our equation here, we're going to get negative 556. So now we can just divide by negative 139, and we find that our z value here is equal to 4. But remember, our solution has to have an x, a y, and a z value. So now we need to start backtracking. Now that we know the z value, what we can do is we can go back up to one of these two equations. Okay? It doesn't matter which, and we can actually find our x value. Okay? I can find x just by plugging in our z value and solving for x. So I'm going to plug it into a. Okay? I've got 2x plus 10z, so I'm going to plug in my 4 here, and that should be equal to 38. So our equation here is really 2x plus 40 equals 38. We subtract the 40, we divide by 2, and we find that x is equal to negative 1. Okay, so we're getting closer. We have our x and our z. We just need to know our y. So you can see this problem is very long. There's a lot of steps. Okay, so now, lastly, we're going to find y. And to find y, I need to take the x and the z value that I already found, and I need to plug those values back into one of my very original equations. And it doesn't matter which one. Okay, I'm going to plug it into, let's say the middle equation. Okay, let's use the middle equation to plug our values back into. So we have 5x, so I'm going to plug in my negative 1, plus y, plus 2z, so I'm going to plug in my 4, and that should be equal to 10. So now I'm just solving at this point. Negative 5 plus y plus 8 equals 10. So if I combine my negative 5 and 8, I get y plus 3 is equal to 10, which means that y must be equal to 7. So now I can actually write my solution. Okay, my solution is that ordered triple with an x, a y, and a z value. That is going to be the solution to this 3-variable system. That is the intersection of 3 planes. So I know that this was confusing. It was a lot of work. And remember, the reason that we're learning this is so that when we learn how to do this same thing with matrices, we can see the value in it. We can see, really how nice the matrices work and how they can take a really difficult, long-winded problem like this and really streamline it and simplify it. So let me know if you have any questions, and have a wonderful rest of your day.